Okay, and I'm going to try and record the lectures. Lecture 2. I kind of forgot yesterday, or Tuesday, whenever it was. There's half an hour of it. Okay, and as I talked about to you guys, the course is going to be a little bit chaotic and not in a normal order. And actually, I talked to you about this. I had a chat with Hannah, when was that? A couple of weeks ago.
Yeah.
I wanted someone to how am I going to deal with this? So you thought it sounded like a good idea anyway. So if it all goes wrong, you know who to blame. So, as you know, I decided, okay, we're going to start with quite a big focus on doing exercises, which I've kind of inherited, but I've changed them quite a bit, but not totally, and I haven't made up any new ones because that takes a hell of a lot of time. And I just didn't have that time. So we're going to do these exercises. There's going to be a lot of focus on that. And then we're going to say, with that, knowing some methods and knowing how these problems can be framed, then we're going to have a huge focus on, okay, let's look at actual environmental problems, how they're dealt with, and why, and also match that to the exercises. And partly, okay, what was good about the exercises and what did we learn, but also what could be done better. Is there a kind of a bit of a free of focus, or a kind of what are we missing? So I hope it's going to work out really well. And it should be, this course is hugely important. If you want to be an environmental economist, somehow we're trying to lay a base here in terms of getting a grip on the subject, because it's obviously an extremely policy-oriented subject. Okay. But we started basically Tuesday with some more relatively heavy theory, which is kind of matching the start of the book. And we've got a bit more of that theory to do, which is basically what we're going to do today. I don't think it's going to take the whole lecture. And then we're going to have some discussion. And then we're into phase 2. And I don't know if anyone saw, but I was hard at work yesterday evening. No, it's not there. I need to be here, yeah. So I've already got some videos up. This is me going through the problems. Okay. Oh, we've got no sound. Can you get sound in these rooms? I guess you can. Seems to be awfully quiet. You can sort of hear that there is sound, can't you? Anyway, they do it on the PC, on my PC, the sound is fine. Again, like if I was doing it again, oops, what did I do there? I clicked on some advert, I think. It would probably be smoother, but it's a reasonable job. I would strongly recommend you, or at least bear in mind, if you think I'm a bit sadlig, you can speed me up a bit, okay? So you can get, yeah. If you think it's a bit come on. Because of course you can always, slow it down. Okay, this is tricky, but if I'm standing there, oh, what should we do next? Okay. So I would strongly recommend giving that a try. Outside of the testing the speed, what is best for you. And basically, I'm totally building a plan around that you actually look at these, right? And I'm definitely planning to skip tomorrow's lecture. I should have emailed you guys, I guess. Sorry about the short notice. We talked about that I was very likely to do that. To give a bit of a gap, so you have some time to actually look at these. And I should get the rest up on Friday, I guess. Yeah, I'm not going to have any time to do that today, that's for sure. But tomorrow. So I should get the rest up. There's 5 sets of exercises. And then the class is starting, I think, on Monday, isn't it? If we skip Friday, it'll be very much like I won't be just going through them again. It'll be questions and answers, it'll be issues arising and stuff. And then I really don't know how long that's going to take. You know, it depends a lot on you guys, and yeah, because I just haven't done this before, this course. But when we're done with that, certainly by week 15, at the absolute latest, but probably sooner, we'll start looking at policy questions and so on. So after I've got these videos recorded, my next thing is to decide on policy topics and find some literature, or choose exactly what literature I want to look at. And obviously that's pretty urgent as well. So I've got plenty to do. But to give you an example, we'll certainly be looking at climate, obviously. And you could have a whole program on climate. Like the LSE, the London School of Economics, they have a master's program in climate change economics. No problem to fill that. It's such a massive issue with so many different economic aspects and problems. So we'll talk quite a bit about climate, but I want to give some perspective from other questions. Very likely we'll talk about lead in petrol, which is much, much simpler. I don't know, does anyone know what I'm talking about? You realise if you're not, I'm gonna, you might be put on the spot. What am I talking about? Does anyone? Julia, you nodded. Yeah, but what about in petrol? What's that all about?
Yeah, you told us.
Oh yeah, that's cheating. Yeah, you mentioned it in the other course. I kind of wanted to get an idea of, without me, yeah, so you guys, who I haven't talked to about lead in petrol. What does that tell you? Alsoy benzene. Does that mean anything to you? Or? It's kind of before you were born. So we used to add lead to petrol deliberately, knowing that lead caused brain damage, but thinking it'll be fine, because it basically means that you can tune up your car motor more highly, so to speak, and get more power out of each litre of petrol if you have lead in the petrol. So just look at the regulation of that over time. Not from we won't be doing the EKC stuff, but it'll just be more like what regulations were introduced and why, how does that match what theory would say should have been done, things like that. And that's really quite a simple problem. We'll look at CFCs for sure, freoner, how is that regulated over time and why. That's quite a nice contrast to climate. It's a lot simpler, but there's similarities in the sense that you've got this globally mixing pollutant that's emitted from different countries all over the world. But there, for whatever reason, we'll find out, there was once the problem was discovered, within 10 years, we basically said we're not going to emit this stuff anymore. And we'll look at least one more case. I've got some spam call coming in, sorry. Yeah. And then the later part of the course, when it's kind of over to you, I'll be looking for you to pick problems and analyze what's been done and why, and link it to some literature. So I think in the past it was more pick a paper and talk about this paper somehow. But I'm kind of more interested in pick a policy problem and then related to that, look at the paper, but also that's how I'm seeing it at the moment. Okay. Yeah, another thing. Because this course is new and it's all a bit, I'm really keen to have good feedback from you guys as we're going, so I'd like to have a student representative right away, someone who can take the pulse of the class and who I can ask a little bit more, put on the spot and say, oh, can you give me some feedback? I can always, I want you to give me feedback at any time, but it would be really good in this case to get someone to volunteer. And of course, are you familiar with the student representative thing we have at SOU? So the key thing the student representative sort of always does is help with the course evaluation at the end, and especially there's sort of comments made by students, and it might say, the lecturer was such an veep, or the lecture was so, and that's not the kind of thing you want to publish, but we do publish completely openly the evaluation, so we have this sort of filter. And so one of the things the student representative does is to sort of filter the comments that were made and write a report about what the students thought in their comments. And you get paid 400 crowns. So it's not going to make you rich, but generally it would take you an hour or two to do this, so it's like... but it also says in the blurb for the student rep that they are this kind of contact person for the teacher, and it should be decided at the start of the course, blah, blah, blah. We can come back to it later today, perhaps, but by the end of the lecture today, I hope we can have a student rep. It's not a big deal. Okay, maybe I'm making it sound like a big deal. Okay. Any questions before I go back to the lecture, or comments, or whatever? Should we go back to it? Okay. Okie doke. So I've actually updated both of these since the previous lecture. Oh, I forgot the notes. I think I took them out of my bag. Sorry, I had some notes I could have given you guys, but I didn't bring them with me. I've updated them a bit since I got kind of in a tangle with this with the gas and coal economy. So I just, as soon as I sat at my desk, it was like, oh yeah, of course, this is how I should have explained it. So then I just made it clearer in the notes, changed things around a bit. So if you want to, you can have a look at that, but I'm not going to go through it again. Okay. Let me see. Okay. So what were we doing in the previous class? We were basically trying to get a grip on a sort of analytical way of conceptualizing the problem facing a social planner, right? And we were also a little bit talking about firms, but mainly we were thinking about a social planner. So what's a social planner? This is kind of pretty fundamental for
Just someone who maximizes social surplus.
right. So they're like, sometimes you say it's a benevolent social planner, that they are so kind. So they're trying to organize things to maximize the total surplus for society. Can you say a bit more, or does someone else want to fill in? There's a few more things you can say, but that's a very, very fundamental thing. Like, how do they do that, this planner? What information does the social planner have?
All information.
They know, or she or he knows everything, yeah. They know everything there is to know, and a bit more. And then what do they actually sort of do?
So they internalize all the externalities.
In a way, yeah, they do. But, well, there isn't really a market, so there aren't really any externalities, you could say, in a socially planned economy. There are kind of different ways of looking at it. But the sort of purest way of looking at it is that the social planner just tells every agent in the economy exactly what to do. Okay. And the agents do what they're told. That's kind of what you're assuming. So, the social planner determines the allocation of resources in the economy, where the most fundamental resource in the economy is the labor supply, and ultimately what you allocate people's labor to is going to determine what's made. But then, of course, there's also what is made. Then when you have intermediate products, what do you do with that intermediate? Someone's digging up coal, but then what do we do with the coal? The social planner decides that as well. Okay. So, the most sort of fundamental conceptual framework for thinking about the social planner's problem is what do we do with our inputs? And of course, in general equilibrium, this is all the inputs in the economy, and this labor is incredibly fundamental. But we can also do a sort of social planner's analysis in partial equilibrium and just look at one part of the economy here. And this is what we're doing here. So then we're just saying that, look, these inputs of this input, which we're calling R, is just available to the social planner at a price WR. And for every unit of R that we buy, this price is counted as a sort of cost to society. So that's part of the social planner's calculus, is that this using amount R as that input costs this. And so on. So the most sort of fundamental conceptual framework is thinking in terms of the inputs. And what should we use the inputs for? How much of the inputs should we use? And we want to choose the inputs. In this case, I call them, there's just two, labor and the resource, to make our good, which I call widgets. And then we've got the cost of buying in the inputs, and then we've got the damages from the emissions, which are a function of the inputs. But we also, okay, and then we can think of it as look, we've got this damage curve, which is coming from here, and we've got this curve showing the surplus in dollars per year, or some amount of money per time unit. And here we've got the emissions. So this is the kind of efficiency frontier in this case, right? So this isn't like demand and supply or anything. And we talked about these three different ways of conceptualizing the planet's problem, right? One is in terms of what inputs to use. That's the top one here. The next one is in terms of quantity and abatement effort. And the third one is just rätt och slätt, just in terms of how much to emit, assuming we're doing it on the efficiency frontier. And then we got these different. I don't know. I mean, have you thought about this before? I'm sure in like the second year environmental economics. Have you all studied some environmental economics? So Alexander, you haven't.
No.
Okay. But typically in second year kind of level, or even first year, some of the problems will be set up in terms of abatement, and the more you abate, the less you emit, and others are set up in terms of emissions. And you might have wondered, like, you have to sort of twist everything around in your head in between these, and it's like, which is this now? Almost certainly none were ever set up in terms of input use. But I'm going to try to sell the input use way of thinking to you guys. Okay, and then we had this input use model. And it turned out that we had inputs of coal and gas. And coal led to emissions of sulfur dioxide. We're worried about sulfur dioxide in this example. Okay. But on the other hand, it's cheaper. Okay. Otherwise, we'd just use gas. If gas was cheaper and never polluted, there wouldn't be a problem. You just use gas. So then, when we plot the net benefits against emissions, we ended up with something like this. So what inputs are we using here? Just so that everyone's back where we were last time. At this point,
Using gas.
we're only using gas, aren't we? And then here we gradually start substituting for coal instead of gas. And here in this white zone, we're only using coal. And then it's just that we're making more and more stuff out here. And remember, this is net benefits. This isn't marginal. So we're never going to go past this point, are we? The planner. But what point is the planner going to choose? And now we're into new stuff, right? I don't think I ever talked about this. So what point is the planner going to choose here? It's kind of a trick question or a kuggfråga. Have a think about it. Okay. Chat to your neighbor or whatever. So there's no simple answer. What thoughts do you have?
We were thinking a bit about this net benefit. Is it the company's net benefit or is it the company's?
Right.
But
It's
it's
just
done-
the
it's
company.
done-
It's not with any damages. We haven't even talked about damages, have we, in this model? Yeah. So there's no damages here. It's like the curve I showed you before, and then with the damage curve separate. So if there were no damages, literally, what would the planner choose then? Right. It would be here, wouldn't it, somewhere? I think it's 0.9 actually when you do the math. Emissions of 0.9. There's units, I can't remember. In the notes there's units, 0.9 tons per year or whatever it was. You could work it out from the notes. And obviously there had been an associated amount of coal being burnt and associated quantity of electricity being made, which we could also work out from the notes. Okay, but if there are damages, what can we say? What will the planner choose? There's one thing we can say.
The optimal amount of...
Okay, but a bit more specific based on this.
Where the marginal cost equals...
Yeah, okay. I'm kind of asking you to read my mind. It's going to be to the left at that point, isn't it? Okay. Yeah. But how far to the left? Well, we don't really know. Might it be here?
Yes, if the damages are big enough, we might end up at a certain...
Kind of. But imagine if damages are... can anyone see any pen? Here's a pen. It'll have to do. If damages are... So what's E? E, yeah. So damages are like 1,000 e to the power of 10. Okay, that seems pretty big, doesn't it? So would emissions be here in that case?
Maybe it would still be profitable to emit a little bit.
It would be, but why?
Because then we'll get a little bit of benefits as well.
See, what are marginal damages? Marginal damages is the slope of the damage curve, isn't it? So dE by dE is 10 to the 4 times e to the 9, isn't it? Yeah? You with me? So what are marginal damages when e is 0? Yeah. So you're never quite going to get to 0, are you? Because the curve here is flat. And this curve has a positive slope all the way to the axis. So you're going to be awfully close, given this, because it's going to go, given that, literally, I mean, you could plot it in MATLAB in 2 seconds, but it's going to go like, but you're never quite going to get here. But on the other hand, if damages were like 10 to the minus 10, well, no, actually, no, that's not good enough. Because then, well, yeah, if damages are sort of 10 to the minus 10 e, okay. So what are marginal damages then? Right. So this is the slope in this setup. Yeah. In this graph, marginal damages are the slope. In an ordinary sort of demand-supply graph, marginal damages are the height, aren't they? Because it's like dollars per ton or something. That's the y-axis has that unit. But here it's a slope. So we've got an almost flat line, haven't we? Starting at the origin. damage is a 0 when E is 0. So then, what are we going to have? The maximum gap between this line and this one is going to be a tiny bit to the left. Yeah, up here. But what if damages are like 10 times E? Or even just, let's just make it E. Damages are E. Look at the numbers. So where's the line going to go? It's got to have a slope of 1, hasn't it? So if we're at 0.5 here, we want to be at 0.5 there. It's going to go through this point, isn't it? So where do we maximize the gap? At 0, yeah. So marginal, in this setup, marginal damages are strictly positive even when you've got 0 emissions. The very first tiny bit of emissions is still causing damage. And actually, when you look at the natural science for things like lead, that seems to be a decent first stab at what's going on. That the brain damage caused by lead, it kicks off with the first bit of lead that gets into your brain. Okay, and then you double it, you double the brain damage. Basically, it's not this idea that, the first bits don't really do anything and then it sort of accelerates. So in this, if you have this kind of damage function, it's just like, look, just go over the gas. Okay. Whereas if you've got this kind of thing, it's kind of trickier. Because the optimum is going to be somewhere in between. It's going to be a mix of them. Okay, so we're going to come back to this because this has massive implications for policy. Okie doke. So, that was kind of recapitulating, but I really wanted to link what we'd done yesterday, Tuesday as well, to a bit more of a policy way of thinking before we go on. Does anyone remember where we actually got to? Was it here, or did we talk about this? I don't think we talked about that, did we? So I guess we got to here. I kind of waved my hands around a bit here and said, well, because we never did these derivations properly, right? But we did this slide. Remember I talked about the 3 ways of formulating problems of this type: input use, quantity and abatement, or just emissions. And this was the relevant equations for this coal gas thing. And I kind of got in a tangle, as I said, when we did the derivations. Okay, but now today we're going to have a bit more of a think about firms vis-a-vis the social planner. The first thing I'm going to do in this slide is just generalize a bit. And, like, why am I showing you all this horrible notation? If you look at the old exams, which I haven't made available yet, generally you don't need to get your head around this kind of notation. It's much more like numbers, 2 inputs, one is this, one is that, you know. But this kind of notation is super important as well to get your head around. And at this stage, it's more about just familiarizing you with it, I guess. I guess you've used this kind of notation in the previous courses. Yeah. But it's a process of getting used to that and not like freaking out when you see equations with like summation after summation and so on. I don't know, maybe you're totally unfreaked out by this kind of equation, or not totally freaked out anyway. Yeah, no, that wouldn't be good if after almost or more than half a year of master's courses. So anyway, I kind of want a pointer really at this point. Maybe I'll try and find a pointer in the break. So what have we got here? This is, which of the three models is this one? It's the input choice model, isn't it? Yeah. And X here is a vector or a set of inputs. Okay. So that's why I've bolded it. And so we're choosing each member of the set to maximize the gross surplus from production minus the sum of all the costs of the inputs minus the damages. Okay, so it's pretty straightforward. And we can also do it in the other two ways. So this is just generalizing to any number of inputs. That's all that is compared to what we did before. But what about firms? So here it gets a bit messier, right? So the top line there is just a bunch of notation, and there's some other, I should have more things there, but it's all the same, right? So big Q is the sum over I of Qi. So what's I, do you think, here? What is I indexing? The firms, yeah. So total quantity of widgets is the sum of the Q1, Q2, Qn, where that's the production by each firm of widgets. So they're all making widgets. Total abatement effort is the sum of all the firm's abatement efforts. Total emissions are the sum of each firm's emissions, where emissions are a function of input use. And so on. This is the gross benefits, this is the costs, which we're going to use in this one, and so on. So what's the planner trying? Yeah, so this is still the planner's problem, isn't it? Doesn't say that, but if we look here, the planner is maximizing for the choices of inputs, the input vectors or input sets for each firm. So this is the planner's problem. The price, which is a function of the sums of the quantities, so it's a function of the total quantity, or the sum of the quantities. The integral of the price over quantity, over the range of quantities, it's the area under the demand curve, minus the sum, now which is I and which is J? Yeah, J is indexing the different inputs and I is indexing the firms, isn't it? So it's WJ is the price of input J, Xij is the quantity of input J used by firm I, and we need the double summation to get everything. And then we've got minus the damages, which is a function of total emissions, the sum across the firms of emissions by each firm. Okay. And so on. Okay. So this is just an example of how you can set this up, how you can set up a planner's problem, taking into account that there are lots of firms out there. Okay. And what can we say then about the necessary conditions for an optimum? So here I made a couple of notes for myself. So like, if we're going to take first order conditions here, what are we going to end up with? Maybe I'll do it over here since you guys are over here this time. Just got to find something to rub this stuff out with. Can anyone see? Oh, there it is. Oh, look, there's some pens as well. Okay. So if we take, let's play with this. Okay, so I'm going to get you to do a bit of work. Take the input formulation and take the first order condition in Xij. Okay. See if you can do that. I'm going to go and get some water. I'll come round and see how you're getting on. So what have you got for me?
I haven't started yet. I just wrote the whole thing first.
Okay, so I'll try not to hassle you then. Have you guys got any land then? Not yet.
No.
Oh, inside, I'm sure you have. But does anyone get anything to show me? We're not going to do a lot of this, but just this once.
man skulle gå
So only part B and
Yeah.
ner så att
Okej, man måste
Något som är bara.
which is the easiest bit.
Du menar så att
Det läste
XI är ju liksom mängden avseende på input, så det finns ju inte
So we've got a
riktigt
whole
gröna.
Nej.
row of like 157 terms there that
Eller
are more
vad är
N
det?
and N.
Jaha, just det, vad gud. Stora är
It's actually
alla.
relevant.
Ja.
Ja, i alla.
De
Nej, vänta.
Yeah. You're just going to get WJ out of that.
Så stora är inte så.
And the summation
Ja.
is this.
Att det summerar alla små
The
X.
summation
Alla
is basically
N.
10 units.
Men du tänker, alltså
Look at imagine
jag har
writing
raden.
all the
Ja,
different terms.
ja.
Det är också
Only one.
Ja.
men alltså om...
Okay.
Eller?
So I'm going to
Jo, men
start
det är
that.
hela tiden inte riktigt.
Okay.
Om i
So I'm going to pass things back to you in a second. But I'm going to start with what I just did with Hannah and Julia, which is I'll say, well, why don't we start with the easiest bit, which is this. Okay. What is this? So I was talking about freaking out and so on earlier. If you just think about writing this out, if there's like 2 firms and 2 inputs, this is a series of 4 different terms. Yeah. Which all have a sort of W something and an X something something in. And then if you think about differentiating that with respect to X something something, you're going to have like an X12, an X11, X12, X21, X22. If you've got 2 of each, yeah? And then you're saying we're differentiating with respect to X11. So with 3 of your 4 terms, what's going to happen to them? Yeah, it's like the Moa. Sorry, that's... they're going to disappear. Only one is going to get left. And actually that is going to be the case whatever M and N are. Yeah? Only one term is ever going to get left here. What's that term? If we're differentiating with respect to Xij, once we've differentiated, what have we got left? You guys know, so you have to keep stum.
WJ.
Yeah! WJ. Yeah. So, if you can't quite get your head around that, park it and look at it later, yeah? So that is super easy. So we're getting a bit more concrete now about what I mean by not getting freaked out by this kind of thing, yeah? It's not so hard. And the best thing to do, if you're struggling to get your head around it, imagine like 2, put these equal to 2, write it down, write out the 4 terms and then do it, and then try to see what the general rule is. Okay, so that's one of our terms. Back to you guys to try and sort out the others. Okay. So you're not out of the woods. Yeah?
Så vad
So, in fact, to make it easier so everyone's looking at the same, why don't we do the next easiest term, which is this one. Okay. Think about this one next. This is by far the trickiest. Yeah. So let's do this one next. So how does this vary when we change little x I j?
Så det blir bara att man... Alltså...
So we've got this, within the brackets there, we've got a summation across lots of different i's.
Exakt.
And all of those terms
Eller...
are going to disappear apart from the one that has the right. half.
Yeah,
Fast vad...
but
Exakt, vad händer
There's
nu?
just a big X, so would it disappear?
And that big X is a set of
Blir inte
x, I, j,
Exakt, var står X?
Men det står i den här. Stora X är
Ja.
över input.
Men det
Så
är det.
Så det är summan av alla grejer.
x
Ah,
I is what? It's x, little x, I, 1, little x, I, 2, if we're in the two input case. In general, it would be little xi1, little xi2, dot, 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 little xi m, with m inputs. But if we're just going to, so it's a set, yeah, or a vector, if you like, of inputs. So this is saying that firm I's emissions are a function fi of its input use, xi1, xi2, dot, 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 xim, if you like. So, let's do this together. Okay, on the board. So we've got the function d of what? Let's do the 2 by 2 case. So we've got f1 of x11, x12. Plus, because it's a summation, isn't it, here? The d is a function of f1 of x11 and x12 and f2 of x21, x22. And note, sometimes this kind of notation on a function can mean this is the first derivative with respect to this input, right? You might have seen that notation. And that is not the notation here. This is the function, the name of the function is f1, because it's the function which pertains to firm 1. There might be different functions for firm 2. Okay. And then we're saying, look, let's take dd by the x11. Okay? So take a concrete example. 2 inputs, 2 firms, differentiate with respect to one particular input for what? For one particular firm. Yeah. So what do we end up with? What can we do with this? Forget it, or cross it out, or whatever. And what's this? It's like dd by the f1, if you like, the f1 by the x11, isn't it? But in a way, we could write, I mean, yeah, it's always a kind of, or there's a bit of a matter of taste here and how exactly what notation you're going to use and how you're going to deal with this kind of thing. Because what this really is dd by the E, isn't it? It's how much D is affected by emissions. It's this whole sum we could call emissions. And then you could say it's really how much is D affected by emissions? And then how much is emissions affected by x11? So if you wanted to, you could say dE by the F1, the F1 by the X11, if you wanted to. But then this is just 1, isn't it? Because it's a summation, yeah. Emissions are the sum of F1, F2, F3. So dE by the F1 is just 1. You add 1 unit to F1, you're going to add 1 unit to emissions. So if we wanted to, we could just wipe that and say this. Although in a way, putting this in, as long as you're aware that that's just 1, it's kind of helping with the intuition of symmetry and the whole thing, right? But ultimately, it's how much of damage is affected by emissions and how much are emissions affected by the use of that input in that flow. So, that's that one. Okay. And what about this one? Okay. So here, it'd be a good idea to draw the graph. And this is P of Q, and this is Q, and that area is the integral, isn't it? Again, I'm kind of cheating a bit with the notation, but the integral between 0 and Q of P of Q dQ is this area, isn't it? And then what happens to this if we raise xij a bit? Well, raising xij a bit, what does that do in this context? It raises qi a bit, doesn't it? Assuming that xij is that kind of an input. It could be an abatement input. It might even you might even lose q potentially. But that doesn't matter for now. Let's just think of it as raising q. Because remember, this is xi1, xi2, xi3, xij, xim. So when we raise xij, we've got a dqi, dxij, haven't we? And all the other ones, for the wrong i's, they all disappear. So the summation goes away. But then, so by raising xij, we're affecting qi. But by affecting qi, we're affecting p, aren't we? And we're also, but we're affecting this q, the total q. And it turns out that that is the key. The effect on the integral is going to depend on how this line shifts. And if the line shifts a bit this way, then you're going to add p of q to the integral. If the line shifts marginally that way. So, what do we end up with? What we add to the integral is p, the height at that point, times how much the line shifts. And how much does the line shift? It shifts by dq by the xij, doesn't it? Okay. Why have I written it like that? Because I'm going to add something here and here, right? And wipe that. What can I add here? Yeah. The Q is affected by QI, the production by firm I, and firm I's production is affected by Xij. But what's this? Okay, over to everybody. Everybody should be able to work this out by this point, I think. What's dq by dqi? Chat to neighbour. Stop there for a minute.
Jag vet inte, men det är ju
Eller mellan det kan ju...
What do you reckon? I can ask you.
Vad sa du?
I don't know how Swedish
Nej,
is.
förlåt.
Did you understand what Hannah said?
No.
No.
It was pretty straightforward.
What's dq by dqi?
Som det är QI och QI säger. Och det är det
So
QI.
q is the sum of qi, you see. Total q, total quantity made is the sum. If you look at the top left,
Jag
there,
vet
it's the sum of what each firm made.
Tycker du att det är rimligt?
Jag tycker det.
Aha, just det.
Do you guys have an answer?
No.
No? Oh, I thought you said the answer, but you said no.
Has total quantity.
So let's just do, if x is x1 plus x2, what's the x by the x1? Right. That's your answer. That's all it is, yeah. So this is the thing about getting freaked out by summations, yeah. That is all it is. See, look at this. Q is just the sum of the QIs. And then we're saying, what's dq by dqi? Take one of the QIs. What do you get? It's just one. Okay. It's the same thing I was talking about here. E is just the sum of the emissions from the individual firms. So how does an add 1 to an individual firm's emissions? What happens? The total emissions, you add 1. Okay. So I thought that might be useful, a bit of a kind of mathematical interlude to try to give you some help in demystifying this kind of thing, or whatever you could call it, making it less scary. Yeah. So try to think with these kinds of things. Think very concrete. Okay. Wow, we've gone way, way over time. Let me just round off in some way. So this is our first order condition, equals naught, but let's put the equal sign here and put a plus sign there. Yeah? You with me? So what's this saying? It's saying that the benefit of the social planner telling firm I to use a bit more of input J should be equal to the cost, the social cost, which is the cost of procuring a bit more of input J plus the damage cost from using a bit more of input J. Oh, so this should be I and Ij. And this should hold across all firms and for all inputs, right? And we'll come back then after a break to what this means a bit more. But I just wanted to give you that context to the whole thing. And now it's high time for a break. How long a break should we have? Should we say 16 minutes? Should we start at 22 on the clock now? Is that okay enough? And then I guess we'll probably have a short break, probably the second one, because of the way the time's gone. Missed about 5 minutes. I don't know, we'll see. Maybe you're all here, so we'll see. According to the what do you call them, whatever, there should be one or two more people, but we'll see. Okay, so what's the interpretation here? It's like every firm, or the social planner should make sure that every firm is always balancing these two things. Which is the sort of, what's this? It's like the marginal revenue product of using more of this input, isn't it? And this is the cost of it. How much it costs to buy and how much it costs in terms of damages. And this is, okay, if we produce more, what do we get out of it? We get, on the plus side, we get the price. On the other side, we get, okay, it's adding to costs and holding A constant, yeah, as always with partial differentials for the given value of A, is adding to damages. And again, we should have a balance. And how do we choose abatement A? Abatement A is not affecting production, but it's adding to costs, but it's, so what's the sign of this? It's kind of obvious about what it has to be, but why am I asking? Because it's negative, right? Well then, I guess you're thinking, okay, why is it negative? So this is G, this is like EI is GI of QIAI, yeah? It's the emissions by firm I, is this function of the inputs. And A is the abatement input that is helping to reduce emissions. Or abatement effort. It's not really about inputs anymore, but it's a measure of abatement effort. Okay, so that's negative. So emissions go down when A goes up. So that's why these two add up to naught, because this is positive. Yeah? Abatement effort is adding to cost, but cutting emissions. Okay. And of course, the planner makes sure, if we took first order conditions here, it would be like B prime, or dB, the little bi by the EI should be equal to the d by the dE by the EI, which is just 1. So that's just saying the marginal benefit of emitting should be equal to the marginal cost, social cost. So that's super straightforward. Okay. Questions, comments, whatever. Shall I go on? So now we're actually going to look at the firms. So we had before, first we just had the planner and we didn't even think about firms. Then we had the planner with firms, but they're still being told what to do. And now we're actually going to look at the firm's problem. Okay. So let me take that away. So the planner is setting out the sort of, if we forget about damages for a minute, the planner is setting out to maximize net benefits, right? this isn't that thing, yeah. This is price against quantity. And the planner, if there are no damages and whatever, you would go out here with. Well, no, sorry. That's not quite right, is it? Because this was actually this was gross benefits before we allowed for input costs. Sorry. But whatever. The planner is looking to maximize net benefits to society. And what is the firm looking to do? In simple terms. Yeah, sorry.
Maximize profit.
Right. Good start. So the firm is looking to maximize profit. And how do we typically break up profit into components?
Revenues and costs.
Revenues and costs. So the firm is saying, I want to maximize pi, which is equal to, and someone else then, revenue, what's that?
P times Q.
P times Q. So this is different from the planner, isn't it? The planner had this integral, but the planner was trying to maximize the area under the curve. Well, that was the component. If that's what the planner cares about, what's the firm caring about? On this, what would the firm's area look like?
The square.
Got it. It's this, isn't it? You with me? And what are costs?
The prices of the input time.
It's the input. We're in the input. Generally, if you think about the firm situation, the very natural way to think about it is the cost of buying the inputs. Yeah. So it's the sum of like W, J, XJ, I guess. If we're trying to get the notation right. But then potentially there's some other costs for the firm, which I think I'm going to call, or I call, let me see now, so I don't. So if we just focus on one firm, so then we can skip the I's, then we've got WJ, XJ, and then we've got minus R of F of X. So what's R then? So R is some cost. Regulation cost is a bit weird. I just made this up, basically. R is costs borne by the firm that have to do not with its choice of inputs directly, but with, it's like payments to a regulator or something. So this could be like tax payments, or payments it has to make to buy tradable permits, or even a subsidy, in which case R would be negative, and you'd have minus minus, and it would be adding to it.
Does it depend on the quantity of the input, or is it just something?
No. So R is only a function of emissions. Well, actually it depends on the regulatory instrument. It could be that you're subsidized to use a particular input, in which case it would, so it depends actually. I thought this was general, but it's not. Typically it would depend on your emissions, which are, I've defined it like this, as a function of your input use. But it could be that actually you get payments for it. It's not uncommon that you get subsidized to do something very specific that is not necessarily to do with a particular input. Well, no, it's not to do, it's to do with a particular input, but it's not to do with emissions. it affects emissions, but it's not the same as emissions. Okay. So this is the input formulation for a single firm, and if we add i's in appropriate places, then it's the input formulation for a general firm I out of other firms. And similar to before, we can also say, look, pi is, sorry, yeah, and I should have had p, q of x here, the set of inputs. And the same as here, f of x. Similarly, oh yeah, and what should I have here? The x's, yeah? Choose inputs to maximize this. But we could also say, choose, guess what? Q and A, the quantity to make and the quantity of the abatement effort to maximize. PQ, now Q is not a function of anything because we're just choosing Q, minus costs, which are a function of Q and A, minus R of G of Q and A, where G is also a function, E is G of Q and A. So we said that E was F of X, but we said then that E was G of Q and A. Why can't we just use F for both? Why do we have to krångla till det, complicate things by changing these letters? Chat to your neighbour. So this is about what we really mean by a function. Yeah. So Janina said it's not the same function, right? So the function f might be like square the argument. Yeah. And this function might be like take the first argument and multiply it by the square root of the second. And that's what g means. So these f and g's, they sort of mean something in that way. So you can't just use the same. Okay. So that's the second way, and then the third way is just maximized by choice of E, B of E minus R of E. Okay. And if, as I said, we can put i's in the appropriate places if we want to think of one firm which we denote as firm I among other firms. So, why is there no I on P here? Yeah. All firms face the same price, right? So that's. And similarly here, yeah. All firms pay the same for input J. If they didn't for some reason, then we would need an I. Okay. I was running out of time or patience by the time I got to this slide. So what are we doing here? What's going to happen in this economy? This is the next question. And this is like the classic sort of economic methodology when we're looking at policy. It's like you think about, well, what would the planner do? And then you think, well, what would happen in laissez-faire if you just let firms get on with it? And then what's the third thing you do? Yeah, but if you find there's a difference, what's the third thing? You ask a third question.
What's the optimal regulation?
Right, what would the regulator do? Assuming you then think, okay, well let's assume there's a regulator who has these instruments at her disposal. What is she going to do? Okay, this is like the classic sort of policy analysis. So the first thing we're going to do is look at what happens in laissez-faire. And I have to apologise for this slide. I never got that pointer either. So the first thing to note then in laissez-faire, this is what the first bit of line there is saying, is that this is 0 each case, yeah? Because there's no regulation, so there's no costs, you don't have to pay taxes or buy permits or whatever, so that just drops out. So then we can do first order conditions. Oh, why don't we write down the third one, which was B prime, or pi is B of E minus R of E. Okay. So in laissez-faire, if R of E is 0, by definition in laissez-faire, then the firm's problem, the solution to the firm's problem is just to set B prime E, or dB by dE, same thing, equal to 0. So you want to be at the top of the total benefit curve. You want marginal benefits of emissions to be 0. What else have we got in this slide? Yeah. And that's not the social optimum, is it? So where's the social optimum? If this is E, and this is dollars per year, remember E could be like this or like this. Remember, this is where we were at the start of the lecture. Yeah? The social optimum is where we maximize this gap. But we just said in laissez-faire, you're at the top. This is kind of, we're right back where we started the lecture, aren't we? So that was for the emissions model. In the input choice model, firm I will use input J in a quantity such that the marginal revenue product will equal its price. So if we go here and take a first order condition in Xj, we're going to end up with P dq dxj equals Wj. Yeah? Or P dq dxj minus Wj equals 0. That's the first order condition, and therefore the price of input J must be equal to its marginal revenue product. The price of the widgets times how many extra widgets we get from an extra unit of Xj, or on the margin. And so on. Okay. So typically in laissez-faire, we're going to have emissions are going to be too high, aren't they, compared to the social optimum, and typically production Q will also be too high in this partial equilibrium setting. In a general equilibrium setting, it's not at all certain that production will be too high. So, how are we going to deal with this? Okay. So, this is just this standard sort of first year, really, environmental economics, where you'll have had this sort of graphs and sort of this kind of thing with marginal abatement costs and damage, I don't know. But now we're doing it like with a lot of equations instead. So what we can do is say, okay, let's assume then that we know what the planner wants to do. We know what will happen in laissez-faire, and then we say, well, look, there's a difference between the two, so we need to do something about it, so let's invoke a regulator and give the regulator some instrument. So what have we done here? We've said, look, let's assume the regulator can impose a tax TOR. A lot of people say TAO, but whatever. I learned to say TOR. I should ask Effie what she says, really, but Julia's supervisor, who's Greek. Whatever. What level of TOR should the regulator choose? How do we work that out? There are basically different ways of doing it. But to me, the most straightforward way is to say, just stick in TOR, work out what happens, and then compare what happens to the planner solution. And say, okay, what TOR do we need to make these identical? Okay. So if we're in the emissions framework, oh yeah, the emissions framework, that's this one. Then we've got the firm's problem is the max by choice of E, pi, which is B of E, minus, okay, no. I'm not following my own advice here. So, what am I doing here? Whose problem is this?
Social planner or
It's
damage?
the planner's problem, isn't it? So how do we make sense of this? Can someone interpret what this is saying? So, the planner, if we forget the Lagrange and think of this as sort of the net social benefits, this is what the planner wants to maximize. Yeah. But the planner wants to maximize this. And so, well actually, yeah, it's the regulator's problem, this really, isn't it? Because the regulator is also benevolent. And the regulator wants to maximize this. But she can't just tell firms what to do. But she can tell them that for every unit of emissions the firm produces, they'll have to pay a tax TOR. Okay. And then what does the regulator do? The regulator needs to look at this. So yeah, I kind of threw myself here by skipping a step. The regulator needs to look at the firm's problem and work out how the firm is going to react to the tax. Okay. And I kind of skipped that here. So this is the firm's problem. But there's a problem with this problem. What's the problem with this problem? From the regulator's point of view. This isn't correctly formulated. Or I mean, not specific enough. We need to make this more specific to the case at hand with the tax. Okay. I want everybody to think about how we need to change this. Okay, it's super straightforward. Chat to your neighbour, you know. So what do you reckon?
How we should,
So the thing is,
yeah.
the firm's problem was maximise the benefit of emissions minus the sort of costs of emissions associated with regulation.
Yeah.
That was what the R was. So what are the costs associated with the regulation if the regulation is taxed per unit of emissions? That's the question. Janina thought about that. Does that sound right?
Yeah.
Do you trust Janina?
Yeah, I do, but
Yeah. It's taught mostly.
yeah.
Okay. So given that we've got an emissions tax, the costs associated with the regulation, instead of this general thing RV, we can say that it's TOR times E. That's what the firm is going to have to pay. Okay. So then, what E is the firm going to choose? The firm, from the first order condition, in E we get what? B prime, or dB by dE, which we can also write as B prime, is TOR. Okay? So, this is important information for the regulator, isn't it? To think about when the regulator is trying to choose TOR. And there's different ways of doing this. This is maybe a bit of an unnecessarily convoluted way, unnecessarily complex. But here we set up the regulator's problem as a Lagrangian, and we're basically saying, look, we've got the benefit, social benefits, we've got the social costs, and we want to maximize that, subject to the fact that firms are going to set B prime equal to TOR. So that's a kind of condition. And then, if we take first order conditions, we're going to end up, if we take the first order condition in, yeah, I really don't like this way of formulating it. I don't know why I formulated it this way. But at the social optimum, we're going to end up with B prime equals D prime, aren't we? dB by dE is equal to dd by dE. So really this doesn't really play any role in the end. But then it's clear that we want to set the tax such that we know that B prime it should be D prime at optimum, but we know that B prime is TOR in reality. So evidently we need to set TOR equal to D prime. The tax should be set equal to marginal damages. And the point is that this applies to all the firms. Because the marginal damages of emissions are the same for each firm. Is that always true? Are the marginal damages of emissions always the same for each firm? It's one of my leading questions. The answer is obviously no, but then well, why not? Under what circumstances is it different? So we've just said, look, damages are a function of total emissions, and total emissions are the sum of emissions from each firm. Okay. Is that always true? So if you think of lead, again, obviously the answer is no, but why not? Think of lead from petrol. Okay. So the lead goes into the atmosphere, and the main damage it causes is that it causes brain damage in kids. Okay. And it's quite straightforward to measure this. You can compare. I said there wasn't any econometrics in this course, but we can talk a little bit about econometrics. So imagine there's some shock in one part of the country, one city, but not in another neighboring city. And imagine, and this shock has to do with lead emissions. So maybe a city introduces some local rules to prevent lead being added. Or there's some other shock that causes people to drive a lot less. And you have data, you know when this shock occurred, and then you have data on kids' performance in school over the period before and after the shock in the city and in a neighboring city. What can you do there? What sort of study would you do? You're going to do a difference in difference study, aren't you? You probably know more about this than me. I can talk about econometrics, but I can't actually do it. But you're going to do a difference in difference study, aren't you? And people have done exactly this and find major effects. Of, among other things, yeah, specifically lead. Okay. So think about this case. So is it the case that the damage from lead emissions is the same per ton of lead or per gram of lead emitted from your exhaust pipe for all the cars in Sweden, if you go back to the 80s when we had lead in our petrol? It's not, but why not?
So does it have to do with the volume of emissions? So the more total emissions in an area, the more damage? So it's like...
Okay, it could have, but actually the damage is pretty linear. So the marginal damages, I think, like I was saying earlier, in a lot of cases, the marginal damages don't change that much. You start losing brain development for every extra gram of lead or every extra ppm of lead, the lead concentration in the air that you breathe. It's knocking a bit more off your high school score kind of thing. I mean, if I'm driving from like Storuman to Umeå, where's the lead gonna end up? Compared to if I drive, I don't know how far it is from Storuman to Umeå. 20 mil, 200 kilometers. If I drive 200 kilometers round and round, back and forth on Kungsgatan, it's more about, it was a relevant point you had, but the bigger point is like, how much of what is emitted to the air actually ends up getting breathed in by kids. And that is going to vary hugely depending on where you emit. Okay. So in practice, and this is the kind of thing we're going to talk about later, the marginal damages from a given emissions is going to vary massively depending on circumstances. Where you emit it, when you emit it, for instance. But in some cases this holds reasonably well. Can you think of a pollutant or two where it ought to hold pretty well? Doesn't really matter where you emit it or when. Carbon dioxide is one, and CFCs is another, because they basically go up into the atmosphere and mix and affect the whole globe. So it really doesn't matter if you emit it in Sweden or the UK or South Africa or wherever. Okay. But if you have this uniformly mixing property, then you basically want to tax the emissions equally across all the emitters. And it doesn't matter what the emitters' costs are for dealing with the pollution. So if you introduce such a tax and that some emitter has very, very high costs for reducing their emissions, what's that emitter going to do? If the tax is modest.
Nothing.
Not a lot, right? Or nothing if it's, yeah, depending on how you interpret what I said. Either not much or nothing. Is that, how could that be socially optimal? Well, it's separating the distribution thing from the social optimum thing, right? It might seem like unfair in different directions. On the one hand, you might say, well, they're carrying on emitting, this is terrible. On the other hand, you could say, well, they have to pay these huge taxes because they have no choice but to emit because they've got such high costs to deal with it. So yeah, I mean, you can spin it different ways. But in this kind of welfare analysis, those kind of considerations don't apply, right? Because we're just looking. Remember what the social planner is just telling people what to do. And then when you compare the regulated economy, it's like, are people doing the right thing? And it's not where does the benefits end up. It's just about whether people are doing the right thing. And if a firm has, or if in the social planner's economy a firm has very great difficulties in reducing its emissions, but the planner really wants the product of that firm, the planner will say, look, you know, do a little bit if you can, but not much, it's fine, you can keep emitting. And that's then what we want to achieve in the regulated economy. So I'm trying to give you a clear insight into the method. I'm not saying this is therefore. This is how policy should look like. This is the economic method. So, or the standard method. If you care about distribution, then you need a different method. What's the standard argument for ignoring distribution? Any ideas?
Efficiency?
Yeah, so you could, I mean, you can sort of say, well, look, distribution doesn't matter, we're just trying to generate the best total welfare. But then people say, well, look, the marginal utility of income differs across different people, so this is important too.
Kind of like we have a lot of regulations in society, so somehow some will get the bad parts of some, and some will get the good parts of some, and it will kind of even out.
Kind of, yeah. I would say it's kind of related to what you said, but I would say the typical argument most commonly made is like, we deal with one problem at a time. So here we're sorting out the environmental problem. If that's causing distributional stuff, then we need distributional policy. Well, but that's beyond the scope of this research kind of thing, because we're just looking at the environmental problem. So we tend to like economists like sort of compartmentalizing their problems. But then it sort of gets interesting when you actually say, look, distribution is really tricky to deal with, and how do we find the best compromise? That's when the sort of research gets interesting, or an example of when it gets interesting, and closer to reality, really. Because in reality, policymakers do have to think about distribution, even when they're thinking about environmental policy. Okay. Let me see. Yeah. So we're staying in the emissions framework here. And we're saying, what about a subsidy? So I'll take that away again. So this was the firm's problem with a tax. What's the firm's problem if you're going to pay them a subsidy? So it sounds like we should have a plus sign, doesn't it? Should we take a break? You don't want to. If we're going to have another break, we need to do it now, kind of. So.
Depends on how much it's.
Like 5 minutes or something. Or 5 minutes. I mean, if we're going to have a break, we'd have like a 5 or 6 minute break, I guess. Or we just keep going. We've had a vote for keeping going, so unless other people. Okay. Wow, you're up for it. Okay. So, yeah, we had this minus tau or tau e, but now we've got a subsidy. How are we going to, what should we put in here? Over to you guys. I need a drink anyway, so I'm going to go and get some water.
Vad sa du? Nej, precis.
Alltså,
Jag tänker att
det kan ju vara en klumpsumma. Här. Ja, men det finns ju väldigt olika småkoder. Och vad baseras de på? Är det per enhet eller är det typ per rening? Eller
det ska vara en liten workshop på det där.
liksom är det
Det är det man ska göra.
Då är det bara...
Ja.
Aha, jag får ju bara
Aha.
jag har inte med de där papperna.
Man får en subsidy för hur mycket mindre, man får en specifik emission och sen får man baserat på hur mycket mindre det tar.
Makes sense.
Så det här är taket. Kul att det där är mycket mat. Visst måste det vara så.
Ja, jag har lagt mig.
Men vad händer om den blir, om man ska börja mera? Då blir det ju negativt. Om man får betala.
Ja, fast du har säkert ekonomiska incitament att inte komma taket då, för då fast om inte en skatt.
Men den här funktionen gör ju så att man får pengar om man ska bli mindre och betala.
Ja, men den kanske bara räcker upp till taket och sen så gills det inte längre. Och då får du ingen skatt ändå.
Men man ska ju betala. Alltså, det känns ju rimligt. Man bestämmer en ekonomi. Så får man pengar om man släpper ut mindre. Men det är så att om man, alltså, är ett sak så blir det negativt om man släpper ut Alltså, och då får man betala för att man ska köpa mycket. Alltså det känns ju riktigt.
Ja.
Fast det kanske
Det är
är som
ingen
du säger.
ren relation då. Det är någon sån här konstig idé.
Okay.
Jag tror det är där, men-
So, this subsidy. What is this? What are we subsidizing? It's not emissions, is it? Or have you got a suggestion? Anyone got a suggestion for me here?
Abatement,
Okay. And what's that?
like for every unit of emission that is abated, I will get something.
Okay. And how do we know how much they've abated? Yeah. Okay.
The abatement efforts we were talking about before.
Yeah, so you could sort of subsidize an input. Like if you need limestone in flue gas desulfurization, you could subsidize the limestone. But then we'd need the input approach, so that would be tricky. Which generally the input approach is much better. But since we're not in that approach here, yeah, I'm trying to illustrate that this whole idea of subsidies is actually really quite problematic. Especially the sort of general idea of subsidizing abatement is super problematic. It's like, well, how does that work? But basically, if you're going to try to do that, you basically need to assume that there's some baseline level of emissions for the given firm. Okay, so here it would be good to have the I's actually. So we say, look, like last year you emitted such and such, say. So for every ton less than that you emit this year, you can have some Smarties or whatever. Are they called Smarties in Sweden?
The candy. You mean?
Yeah. So then we could write something like this, yeah? So if E bar is what they emitted sort of last year, or it's the baseline, then for if E I, oh I put an I in now, but yeah, put some I's. If EI is less than E bar, you're going to get some subsidy. Okay. This is really tricky in practice, the idea of subsidizing abatement. The idea of subsidizing abatement inputs or investments in clean technology and so on is fine, and that's really common. But the idea of subsidizing sort of abatement is kind of tricky. Anyway, this is it in the math. My next question is, how does this relate to the tax? Can you see any similarities or differences?
We talked a little bit about that. So if you emit more, then that whole thing becomes negative instead. Or
Yeah, absolutely. So if we just cover this, if you imagine that E bar is 0, what does this look like? It's the same, isn't it? But we've changed the tau to a sigma. Because it was plus minus. It was minus EI tau, wasn't it? So actually, and what's this? This is a lump sum transfer to the firm, isn't it? You can call it that, yeah. It's just, here's some cash. And then you say, so we can think of it that way. We give the firm just a lump sum, and then we say, we take back money in proportion to their emissions. So the only difference from the tax is this lump sum. So in this kind of partial equilibrium setup, this is Yeah, well, what can we say? Is this going to be socially optimal if we set sigma equal to d prime? Is it going to be socially optimal? If we think of the social planner who only cares about what agents do, are the agents here going to do the right thing? They are going to do the right thing. The only difference is that you're transferring cash to the producers. But they're still going to emit the same as in the tax scheme. It can get more complicated than that when you start thinking seriously about how many firms there are in the market. So like, imagine you said, so yeah, the tax gives an income to the regulator. No, it doesn't. It gives an income. Yeah, the tax gives an income to the regulator. Oh, we're still on tax. What is the effect of the tax income on the welfare analysis? There's no effect, yeah. At this simple level where we're ignoring distribution. Subsidy. Again, it doesn't affect the welfare analysis in this basic analysis. I don't get the idea that economists never do the stuff that I was saying was more interesting when you start looking at both distribution and the environmental problem together. It's more like in the textbooks. We don't talk, especially depending on the level of the textbook, we kind of ignore this stuff. But this is the kind of thing we do research on, yeah. Okay. Okay, so imagine then that this E bar is the same, you just say to all the firms, any firm in this sector will give you a lump sum payment of sigma E bar, and then will take away from that depending on your emission. What's going to happen? Imagine you hear about this and you're a profit maximizer. A cynical profit maximizer. And you hear that the government says, if anyone comes up, so Stefan says, like, if you're in the widget line of business, just come to me and I'll pay you sigma E bar, and then I'll take back sigma EI later. What are you going to do?
I guess it would differ a lot, like between companies, like some.
But I'm thinking, imagine this is you. You don't currently have a widget company, but you're a cynical profit maximizer. And
Spend it.
Well, you have to. So at the moment, you're not getting this payment because you're not a widget producer.
You would enter Chromatica.
Right.
And then produce nothing? Or?
Right.
Yeah.
That's what I'm kind of thinking. It's like this is totally, it just doesn't really make sense, does it? The idea of sort of paying out a general subsidy for abatement doesn't really make sense because you have to set a sort of baseline and then it's like. But you could say, look, like I said before, well, all the firms that emitted last year would sort of pay them for emitting less this year, but even then, it's like, it's not really going to happen. So there's some quite odd discussions in textbooks and sometimes in papers about like what are the effects of subsidies on kind of, you know, entry and things. And to me it was like, well, you're just going to pile in, everyone's going to go in there and produce nothing. Okay. Permits are a bit like the subsidy. So what have we got here? This is looking really similar, isn't it? But now we've got an EI bar. Well, we probably should have had an EI there as well before, shouldn't we? So this is an initial allocation of permits to firm I. And this is their actual emissions. And phi here is the permit price. So if you get given, if say Stefan gives you 10 permits, but you're like 10 tons, and you only emit 5 tons, you can sell 5 tons at the market price for permits to the other firms, right? So this is really, really like the subsidy case. But now it kind of makes more sense, and you can actually sort of talk about actual mechanisms that make sense. So, and it's the key thing is how are these decided? So how can you decide these E bar I's? Does anyone know? Like, how is it normally done?
Wouldn't it be how much you want emitted in total divided up on the number of companies or something?
Right. So generally you're going to have an idea about your total emissions. Good. So you want the regulator has an idea about total emissions, big E bar, and they're going to make sure that the sum of E bar I's that they distribute to the firms in some way is equal to E bar. But then how do they decide how do the firms actually get them, or how does that work? There's different ways you could imagine doing it.
Either you distribute them or you let them down.
Right, so you can just say, Stefan can say, look, I've got E-bar permits, come and get them, but you have to pay. And then somehow you need some kind of mechanism for Stefan to decide on the price. But then over time, if Stefan is sort of releasing them over time, a sort of market equilibrium will emerge, I guess. An alternative is to give them away. And if you give them away, it'll typically be in the way that I talked about with the subsidies. It's called grandfathering. You will basically give them to firms on the basis of their previous emissions. But if you want to bring down emissions, it'll be you can have 90% of what you emitted last year, and then next year it might be 90% of that. And of course, again, in this simple analysis, it doesn't matter which you do. In more complex analysis, it makes a difference, partly because you care about distribution, and we know that Stefan likes bringing in money because he can then pay for health services, medication and stuff. So then it's good to sell the permits. On the other hand, the firms get pissed off and they lobby against it. So there's all these different aspects to take into account. But at this level of analysis, it doesn't matter, because as long as you sell the right number, the key is to sell the right number, or to give away the right number, so that the price phi ends up equal to D prime. Yeah. When all the firms have done their stuff, the emissions price should be equal to marginal damages. Again, given this uniformly mixing pollutant, yeah. Okay, yeah, we've got that even in the slide here. The regulator needs to sell the right number of permits or give them through this grandfathering procedure. There's other ways of doing it too. Okay, let me just check what we've got left to get through in the... Okay, not much. So, I've thrown in a few sort of random things which cause trouble. Or maybe only one, actually, which was the... I already forgot what it was. Yeah, the mixing thing, yeah. Maybe I threw in something else too. Did I throw in anything else? Whatever. But there's a bunch of things like that, right? Well, distribution we talked about as well, yeah. There's a bunch of stuff like that that causes trouble. Actually, a really, really important one is the measurement problem. So like, if I'm Stefan, if we stick with the petrol, how do I know if I want to tax petrol, tax lead additions to petrol? Or no, if I want to tax lead emissions to the air, which is what the theory would say I should do, assuming it is uniformly mixing, which it isn't, how can I tax people's emissions of lead to the air when I don't know? Am I going to chase around every driver and measure what's coming out of their exhaust pipe? If I want to tax sort of farmers, we were talking about Friedrich's thesis, if I want to tax farmers for their nitrogen emissions to the Baltic, how am I going to do that? Am I going to set up sort of nitrogen measurers in the water courses that are on every farm, the ditches and things leading out of the farm, and the rivers above the farm and below? There's a huge measurement problem in terms of applying these taxes in general. Sometimes it's easy to solve. Like with lead in petrol, it's easy to solve. And so how would you solve it with lead in petrol?
Maybe it's tax when you buy it.
Right. Because basically all the lead in the petrol is going to end up in the air. So you can tax the petrol rather than the actual emissions. But for the farmer, typically that's not the case. Or not typically, but often it's not the case. So the farmer applies nitrogen to the field. Hopefully most of it ends up in the crops, but some of it ends up in the water. How do you deal with that? It's a nightmare. Okay. Another problem facing the regulator is uncertainty. The regulator might not know how firms are going to react to a tax. And the regulator, if we think, well, then we'll put permits in, then we know the emissions. But then the regulator doesn't know how costly that's going to be to the firms. Okay, so if you apply a tax, you know that on the margin, firms are going to be having these costs. If you sell permits, you know that they're going to emit this total amount. But things you don't know, unless you're the social planner who knows everything. So this is just another example. We're just kind of throwing around a few thoughts at this stage. So what's going on here? We're in an abatement framework here. And this is benefits of abatement. So this has to do with the damages caused by pollution. Because when you abate, you have less damages. So when these benefits are steeped down, what's that saying about pollution damages? This is marginal benefits, yeah, dollars per ton or.
That it's very expensive to abate.
No. So this is totally about. So this is not the cost. This is the cost of abatement. This is the benefits of abating. And it's basically saying, when we're not doing any abatement, the benefits on the margin of abating a bit are huge. Which means that the drop in damages is huge for the first unit of abatement. But the more we abate, the smaller the drop in damages is. So if you think of lead, is that curve fitting my story about lead? Julia's shaking her head.
It was quite linear.
Right. That each unit of lead or each ppm of lead you breathe in is destroying a bit more of your brain, kind of, or the kids developing brains. So the damages start at the very first unit of lead and they stay about the same on the margin. So that would be a horizontal benefit of abatement. Each unit of lead you get rid of the atmosphere gives similar benefits to the previous unit. Okay. Whereas this is saying kind of it's a catastrophe if emissions are too high. And if we can just get them down a bit and avert the catastrophe, that's like massive. But then beyond that, the sort of marginal benefits of getting rid of more and more are going down more and more. Okay. And then we're saying, we know this curve. We've done studies of brain damage in kids or whatever, and we're assuming we know this curve. But we don't know how firms are going to react to a tax. We don't know their costs for abating. So if we did know, we would set the tax at this level to get the crossing point, and if we sold permits, we would sell this number of permits to get the crossing point. Yeah. But imagine we think we know, and we set that tax, but actually firm costs are here. Okay. Then what's going to happen? For a given abatement, firms have much higher costs than we thought, don't they? So they're... Okay, I'll let you go. No problem. So see you on... It's Monday, isn't it?
Yeah.
Not tomorrow. Trevlig helg, brukar jag alltid säga till alla. Jo. So, and I guess Elin's going to be the student's representant now. Okay. Yeah. So we don't know firms' costs, and it turns out they're much higher than we thought. If we'd known that they were this high, we would have set the tax up here, wouldn't we? That would be the optimum. But given what we thought they were down, that this was the cost, we set this tax.
firms are only going to abate that much. And compared to if we've got it right, we're losing that amount of social benefit. But if you compare to the permit case, if we release this number of permits, when the true costs are like this, and we think, we should have released slightly fewer, but the deadweight losses are only this. So this is a kind of a classic result. People love it. Or, I don't know. I don't know how important it is, really. It's basically saying, if you're uncertain about firm costs, so you don't know how they're going to react to your instrument, or what their costs are going to be when they react, in the case of permits, then your choice of instrument is going to depend on how steep the benefit curve is, the benefits of abatement. So it's how strongly marginal damages change at different emission levels. Basically, if marginal damages are incredibly sensitive to the emission level, you really want to achieve the right level of emissions. And the way to achieve the right level of emissions is by releasing that number of permits. On the other hand, if this had been really flat, then it's not so much about achieving the right level of emissions, it's about achieving the right abatement cost on the margin. Because then you see the triangles would switch. And then, if this had been very flat, a tax would be favoured above instead of the permits. If you fix the permit price, then you could end up way off. Okay. It's a sort of famous result. I think it was Marty Weitzman who came up with this in like the 70s or 80s when they first started discussing permits instead of Pigovian taxes. So Pigou, he wrote his stuff in 1920, and then in the sort of 60s and 70s this idea started coming up, what about tradable permits? We could do it that way. If we're uncertain about benefits, but not the firm's costs, it makes no difference. Okay. The interesting situation is when we're not sure about how firms are going to react to the instrument. Okay. So what have I been trying to do? I've been trying to give you a sort of baseline story and introduce you to some of the slightly tougher mathematical notation and stuff mainly just to sort of familiarize you with that. But to give you a baseline story about the social planner, firms in laissez-faire, and a regulator, and then focusing on the simple case with perfect information, uniformly mixing pollutant, no market power, no one cares about distribution. We could add a bunch of other things. No risk or uncertainty. We know it's like we could just not know what damages are because we haven't studied enough, but it could also be that we just don't know the outcomes because it depends on whether there's a freak storm or not, and we can never know whether there's going to be a freak storm. So there's so many different things that play in. Yeah, and the transaction costs, can we measure? It's a hugely important one. Can we actually measure firms or agents' emissions in reality? So these are the kind of things we're going to be talking about. And the problems are picking up on 3 or 4 of those things, like market power, the non-uniformly mixing, and a couple more things. So looking at some of those complications mathematically kind of. But then once we've done that, we're then going to start looking more intensively at sort of cases and trying to get a grip on how these things pan out in reality. Okay, so I want to find a student rep, but before that, any questions or comments on that? So, yeah, please get in touch with me if you have questions or comments anytime. Otherwise, yeah, have a look at the videos and the exercises. It's up to you if you want to try and do the exercises first, or that's totally up to you. Okay, I'm going to stop the camera there.